Hi, so you want to contribute to the MITE website and would like to prepare an entry. In the previous video, we've discussed how to do that in general, but here let's take a look at how to draw reactions, SMARTS, and SMILES. And for that, let's take a look at the publication of today, and it's going to be this paper here describing a cytochrome P450 biarylidide synthase, which is modifying this pentapeptide with this biaryl bond. So of course, we could go now to Catcher and start drawing this manually. Catcher has also a very nice structure library, so we could start looking for methionine. Then we do L-methionine and edit and so on, right? But there is a better way of doing that, especially for peptides. On the MITE website, we have this nice functionality, a SMILES generator for peptides. So in this case, you would just type in MR HEY, press an enter, copy the SMILES string, and it's already pre-manufactured for you. So in this case, the reaction is happening between this histidine in the 3 position and tyrosine in the 5. And these are basically now the steps that we have to perform to create our reaction SMARTS. So we have our substrate. Before we start discussing that, we have to step a little bit back and talk about what reaction SMARTS are and what the difference to what SMILES is. So the main difference between reaction SMARTS and SMILES is that reaction SMARTS are a form of pattern matching language for chemical structures, for SMILES. So that basically means that we describe a pattern that we want to search for in SMILES strings. In the reaction SMARTS is a step further, and it not only describes a matching pattern, which would be here on the substrate side, but also some modifications that we want to introduce, and that would be the product side. So in this case, our enzyme can take a substrate like that. So then we draw a reaction arrow, and we simply input the product on the product side. Before we continue working on that, we have to do 2 things. One of them is we have to convert everything in the aromatized form. So from the Kekulé in the aromatized form, in this case, nothing happens because it's already in aromatized form. But sometimes we have the Kekulé form, which is the old school this format. And when we do that, we have to, so this isn't aromatic, at least not for the computer. So we have to first aromatize it like that. See how this changed here? So let's delete this again. And after we've aromatized all the rings, we have to map the atoms. That's important for downstream processing then, and also makes everything much more human readable. So that basically just adds these small indices here on both sides, the same things. So in this case, the reaction is quite easy. So the tyrosine here attacks this position here on the histidine, and we are finished. This is our reaction SMARTS. We mark everything with Control A, press Control S to select the export format, press on Daylight SMARTS, and that's it. That's our reaction SMARTS. If we want to instead produce SMILES, we would simply delete. Well, that was unexpected, but not an issue. Yeah, we simply delete, let's say, the product side. Just mark everything here. Control S. Go to SMILES. Daylight SMILES. And this is a SMILES string. As you see, the numbering isn't even included because for a SMILES, it doesn't make any sense. You can go back this looks a little bit strange. Yeah, but we can also delete this side here, and we have well, not the product yet, but now we would have the product. We can just mark it, export this as an daylight SMARTS, and that's basically it. So now there are, of course, some caveats, or let's say there are some additional options. Some databases, like for example the RIA database, they are really into balanced reactions. So that means that the stoichiometry on both sides stays the same. So in this case, if we have a reaction like that, then we basically lose here a proton and here a proton. So then to make this really balanced, we would have to then add protons here or something like that. Mite doesn't have to, so doesn't want to have this. The mite database should be as generalized as possible. We don't care about balanced balanced reactions. This is something that RIA is doing much better, of course. We are trying to characterize reactions that are difficult to characterize in a balanced manner. If it's really, really important, for example, if you have some kind of dimerization or so, balanced reaction can be included, of course, but ideally try to be as generalized or general as possible. What else? Sometimes in some papers you see these kind of before I continue, all these things that I'm describing here, they are also available in a tutorial. So you don't have to always watch this video. You can just check the tutorial or the frequently asked questions or the troubleshooting pages if you run into issues. And if you find something that is not described by these pages, please get in touch with us, opening an issue on GitHub or sending an email. So one big caveat that can happen is there are some publications that, let's say, explicitly describe H atoms, especially if it's something like, so this is a made-up situation. So let's say it's something like that. Let's turn this to an H, and let's make it indicate chirality. Something like that is not suitable for mite. If you really have to indicate chirality, then please don't indicate the proton like that. Ideally, delete the proton and do something like that, right? Because protons or hydrogens in this case, they are not visible, are not part of reaction SMARTS. They only lead to issues, and it's more of a I would say cosmetic thing to indicate them. So if you have to indicate chirality, please indicate this with the heavy atoms, like that. Okay, I think I have discussed the most important things about reaction SMARTS and SMARTS, and I hope you found it interesting, and we are looking forward to your submissions. Thank you very much.